Greetings, we are Group 7. My name is Lenoah.
I'm Gopal Chaudhary.
I'm Naveen SD.
We will be presenting our computer networks assignment. Naveen will talk more about the problem statement.
Okay. In this assignment, what we are doing is we are setting up a small network, and we are trying to explain how static routing works and how dynamic routing works with RIP and Ospf. In task one, we will be explaining task one A part in this section. In this section, what we try to do is we set up 3 Linux systems, and we will try to we have like 2 interfaces between those all the 3 Linux systems. As you can see in this picture, we are just trying to implement the top layer, and we will try to communicate between each interfaces to each machine to each interfaces with static routing. That's our part A. And now I will invite Gopal to explain how the IP address is divided in between like all the networks and interfaces.
So now we have the network of the base address as .64/26. So now what we do is we divide it into 4 networks. So what we have is we 27th and 28th bit, which is make like 00, 01, 10 and 11. So we have 4 networks. So for example, like here what we have is machine 1 with like 65/28 as the upper interface and 81/28 as the address for the lower interface. Similarly for the machine 2, lower interface address 130/28 and 68/28 for the upper interface. Similarly for the machine 3, 74/28 and 97/28. Yeah, and now I'll ask Naveen to explain about the machine setup in the virtual box.
Okay, I'll explain how the virtual box is set up right now. Okay. Okay. Yeah, this is our virtual machines. These are the 6 VMs that we are trying to use for this experiment. This Naveen Light 1 is the first machine 1, and it will have 2 interfaces. And it has 2 internal networks attached to it. First one is internal network 1 and internal network 4. Then we'll go to Lenoah Light. That's the second machine, and it will have two internal networks, internal network 2 and internal network 4. Again for 3, Gopal 3, we have internal network 3 and internal network 4. Then similarly, child part comes in the task 2, but in Naveen child we have internal network 1, and Lenoah child we have internal network 2, and Gopal child we have internal network 3. As you can see that in machine 1, machine 2, machine 3, that is in Naveen 1, Naveen 2, Naveen 3, that's it, Naveen 1, Lenoah 2 and Gopal 3, they 3 have a common internal network, that is internal network 4, and each main systems have their children attached in separate internal networks. Now I will invite Gopal to explain how the initial setup is in the machine using commands.
Okay. So now initially we'll see that using the IP route command, like we don't have any routes configured at present. And when we use the command IPA, we get the IP address of the machine itself, which are basically here 81/28 and 65/28, which are the upper and lower interfaces itself. Now I'll ask invite Lenoah to explain the IP route setup for the static thing.
So basically what we'll be doing now is we'll be informing the machine about how to communicate with the other machines. So here we'll be telling the route. We'll be adding the route that the lower interface of the second machine can be reached via the upper interface of the first machine. And just like that, we'll be telling the lower interface of the third machine can be reached via the upper interface of the first machine. Now we have to repeat this process for all three machines. So in the second machine, we can see that there are no routes configured already. We can see the IP addresses of the two interfaces. And now we have to add the route. So we'll be telling the second machine the route, how to reach the lower interface of the first machine via the upper interface of the second machine. Followed by the lower interface of the third machine can be reached via the upper interface of the second machine. Similarly, we'll do the exact same thing for the third machine. There are no pre-configured routes. Here are the IP addresses of the interfaces. Now we'll add the route to reach the lower interface of the first machine via the upper interface of the third machine, and to reach the lower interface of the second machine via the upper interface of the third machine. And now Gopal will will show the IP routes.
Okay. So now we'll check whether the routes are configured or not. So we use the command IP route, and now as we see, we have this thing dots 96/28 via .20.65. So basically 65/28 is the upper IP address of the machine 1. So and 96/28 is the upper IP address of this 96/28 is for the machine 3. So we so basically machine 1 to machine 3 the routes are configured, and similarly for the 128/28 is basically for the machine 2 via the .20.65 which is machine 1. So we have the IP routes configured for the machine 1. Now we check the similar thing for the machine 2. As we see, we have .80/28 via .20.68, which is basically .68 is for the machine 2 upper interface, and .80/28 is for the lower interface of the machine 1, and similarly for the machine 3. And now we check for the machine 3 whether the routes are configured or not. As we see, .80/28, .80 is for the machine 1's lower interface. So we have like via this machine 3. Now we'll check how the machine 1 can communicate with the machine 2 and machine 3. Similarly, machine 2 with machine 1, machine 3 by using the ping. So we use the ping command, and 172.16.20.68. So .68. So now as we see, we use here the source is .65 and the destination is .68. So .68 is basically the upper interface of the machine 2, and the source is the machine 1's upper interface. So as you see, the packet is received in the Wireshark. Now we'll try the similar thing for the machine 3's. So .74, that's the IP address of the upper interface of the machine 3. Now as we see in the Wireshark, again the source is .65, which is the upper interface of the machine 1, and .74, which is the upper interface of the machine 3. Now we'll check with the machine 2's lower interface, which is .113/28. Yeah. So now as we see, again in the Wireshark, the source is .65, which is the machine 1's upper interface IP address, and .113, which is the machine 2's lower interface IP address. The packet is received in the Wireshark, as seen in Wireshark. Now we'll check similar thing for the machine 3's lower IP address. .97, which is the IP address of the machine 3's lower interface, and as seen in Wireshark, again the source is .65 and the destination is .97. So this is part 1A. Now we'll move on to part 1B.
Okay, now we'll try to demonstrate task 1 part B. In task 1 part B, what we try to do is we try to implement RIP protocol and we'll try to convert the three machines that we used earlier as routers, which uses RIP protocol, which uses distance vector algorithm, which is basically Bellman-Ford algorithm to calculate the shortest path to reach which interface that it needs to reach in that network. Okay, now, uh, okay, now I will show that from the previous setup, what we did now is we rebooted all our VMs, all our three VMs, so that all our routing tables will switch back to our initial routing table, because all the static routings that we gave earlier would be cleared when we reboot. We'll just see that. We previously rebooted our system, and this is our first machine. And first machine, I executed the command IP space route, and you can see that there are just the interfaces that are attached to that particular system, and yeah, no other routes are there. Okay, you can see similarly that routing tables are clear in all other systems. When Lenoah explains the configuration file, I'll carry on to Lenoah. I'll ask Lenoah to continue.
Okay, so we'll be configuring Zebra and RIPD here. So initially, first we'll have to enable them. So we'll first go to the daemon configurations, and we will tell Zebra and RIPD to stay awake and run in the background. Now we will be configuring Zebra. So when we go to the configuration, you can see that we are manually telling the IP addresses of the two interfaces of this machine. You can find out the name of the network parameter by going to IP space A, and we are manually adding the IP addresses here. Moving ahead, we'll be doing this for the other two machines as well. So first, again, we'll have to enable Zebra and RIPD so that they will keep running in the background. And then we will be editing the config for Zebra. Pardon, 1 second. Yeah. Once that's done, we will do it for wait, this is the second machine. So here we set the IP addresses for the second machine. 113 will be the lower interface and 68 will be the upper interface. And now we will do the same thing for the third machine as well. First we have to enable RIPD and Zebra. Similarly, we have to configure Zebra so that we have to add the IP addresses of the interfaces. Here 97 is the lower interface and 47 and 74 is the upper interface. Now we'll be doing the configuration for RIPD. In the configuration for RIPD, we are setting it up as a router now, and we have to mention the version of RIP we are using. Here we are using version 2. Then we have to also add the supernet. We have to do the exact same thing for all of them. So here we are doing it for the second machine. And now for the third machine. Once that's done, we have to now manually start the service. So we will be doing that with sudo systemctl start Zebra, and then sudo systemctl start RIPD. As you may notice in the side here, we have RIP packets being sent out. We'll discuss more about that later. Now, if we check use sudo systemctl status RIPD service, we'll be able to see that RIPD service is active and running. Now we have to start the services for machine 2 and machine 3 as well. So now we will do it for machine 2, sudo systemctl start zebra. Then sudo systemctl start RIPD service. And you can notice as we start the services, there are packets being sent out and there are responses as well, RIP packets. This will be explained more in depth after Gopal shows the outcome of using RIPD and Zebra together. Now Gopal will show the routes.
Okay, so now if we remember in like before, the router 1 has no routes configured, like it was the same, that system itself, that machine itself. And after we apply do the process of like this RIPD and Zebra activating that, now if we do the IP route, now if we do the IP route, we see that we have 2 routes configured and it is done by the RIPD, and we didn't manually add it as we did it in 1A part. Now as we see it here, like .96/28, which is basically the like machine 3 lower interface, like machine 3 is lower interface, and similarly the 112/28, which is the lower, like machine 2's lower end, like machine 2's network. Yeah. And now we similarly check for the machine 2, like as you see here, again there are no routes configured, and if we do now IP route, we have again like .80/28, which is basically the machine 1, and .96/28, which is the machine 3. This is done by RIPD. And now we check again for the machine 3. There are no routes configured initial, like before. After we do the Zebra RIPD thing, after we check that IP route again, like it detected the another two, like route 1 and route 2. That's a .80/28 and .112/28. Yeah. Now we'll check if the now we'll do the communication between the machine 1 with machine 2 and machine 3. Like similarly, machine 2 with machine 1, machine 3, and machine 3 with machine 1 and machine 2 using the ping.
Before we get to the communication between the machines, we can see that there are request and response RIP packets being sent. So what is happening here basically is, as soon as we start the RIPD service, the machine is the router. It's the machine. It is sending out its routing table to its neighbors, and its neighbors are sending its own routing tables back as response. So that way, the routes will be configured automatically for us. So we can see the RIP packets all over here, both the requests and the responses. Now Gopal will move on to the ping communication.
Now we'll do ping 172.16.20.68, which is basically the machine 2, the upper interface. So as we see here, we have the ICMP, like .65 is the source, which is the machine 1, and .68 is the machine 2's upper interface. So the packet is received by that, and like we are getting the response. So it's successful. Now will we do with the machine 3. As we see, as we see here, ICMP. Now we will do with the machine 3, like .74. Again, as we see in the Wireshark, we are getting the like source as .65 and .74 as the destination, which is basically the machine 3. Now we will do with machine 2's lower interface dot 113, and again as we see in the Wireshark, the source is dot 65 and the destination is 113, which is the machine 2's lower interface. Similarly for the machine 3's lower interface, which is dot 97, and as we say in the Wireshark, like it's being received like dot 65 and dot 97 as the destination. Similarly for the machine, like we'll check for the second machine. Dot 16, dot 20, dot machine one's machine 3 basically dot 74. And as we see in Wireshark, again the source is dot 68, which is basically the machine 2, and dot 74, which is the machine 3's upper interface. Now we'll check with the like lower interface of the machine, like machine 3's lower interface dot 97, and as you see the source is dot 67, 68, and dot 97 as the destination, which is machine 3's lower interface IP address. Now we'll check. We'll go to the
Okay, so now we'll start the demo for task 2B, task 2A part. Okay, for task 2A part, what we do is we have 6 systems actually. Inside 6 systems, the first 3 systems that we mentioned before are the routers, and we set up the routers similar to how we set up routers in the task 1B part. Then one thing to note is that in the router settings, in the router machines, there are 3 router machines. In those machines, we have to edit a system configuration to allow IP forwarding, because when we have children's also to each router, what happens is we have to transfer data from one child in one particular router's lower leg to another router's lower leg. So we are hopping multiple routers. So there should be IP forwarding enabled. Okay, that is the thing to note. Then inside in the demo, I might be using a command called stop all and status all. That's just a bash script to check the status of RIPD and Zebra and Ospf, just to ensure that I have not yet started any of the protocols, so that we are doing it as fresh itself. Then one more thing to notice. Yeah, that's all. Stop all will stop all the services. Okay, now I will invite Gopal to explain the theory about the interfaces of children and all the stuff, all the routers.
Okay, so as we discussed in the part 1A and part 1B, we had divided it into 4 networks. So like Internet 4, Internet 1, Internet 2, and Internet 3. The machines will be act as routers, like router 1, router 2, or router 3, like that. And now what will happen in this part, what we'll have is we'll have child machines for each of the routers, like in each of the internet, like each of the internet, Internet 1, Internet 2, Internet 3, and Internet 4 will have ranges of this. Like for example, this has like .81/28. So the range for this internet is basically like 80 to 95. And similarly for the Internet 2, the range will be like 112 to 127. And similarly for the Internet 3, that's like this part, the range will be like 96 to 111. And for this, it will be like 64 to 79. So we just take like we assign the IP address of each like child node in that Internet 1, something between like 80 to 95. So we just take 85/28, and similarly for this like 112 to 127, 115/28, and similarly for this like 96 to 111 in between something. So 98/28, and each child node here will have a gateway to the router, like basically this thing, the 81/28. So this is about the like arrangement of the systems, like child and the routers. Now Lenoah will talk about it.
So Now we'll move on to doing this practically. So the first thing we have to do, it is something that we already did in the part 1B part. That is, we have to set the IP addresses of the interfaces within Zebra's config. Here, we're just using the stop all and the status all bash scripts that Naveen talked about before. It is just sudo systemctl stop or sudo systemctl status zebra RIPD and so on. After doing the configuration for Zebra, we need to do the again same as part 1B, part B. We have to do the configuration for RIPD. Okay, so then over there again we are setting it as a router. We need to tell we are using version 2 of RIP, and we need to mention the supernet. You have to do this for all the machines. So this is for machine 1. It's for machine 2, which is Lenoah Lite 2. And this is for machine 3. This is Gopal Lite. 3. This yeah, as we can see, we haven't started the services yet. Now we will go to the children. Yeah. So these are the 3 children machines that we have. So this is Naveen child, which is connected to the Naveen router. This is the first router. So here we will be setting the default gateway. Okay. So we go to the IPv4 settings and we set the default gateway. To explain what the default gateway is, so this machine is within the .at subnet. So if it knows how to communicate with other machines within the same .at subnet, but if it has to communicate with something outside of that subnet, then it will just forward those packets to the default gateway, and that is what the default gateway does here. So here we are setting the default gateway to that Naveen router, which is .81. That is the lower interface of the router 1. And here he's disconnecting and connecting the network adapter so that we restart the network manager. You can do it via terminal as well. We just did it with the GUI. Oh, right. So this is the here we can see when we type IP root, it shows default via .81. So it is set. We have set the default gateway as .81. Now we have to repeat the process with the other machines as well. So here we can see there's no default gateway. So now we go to edit connections. We go to the IPv4 settings, and now the gateway for this will be .113, which is routed to. And now if we disconnect, reconnect to restart network manager, and if we check the default, if we check IP route, we can set that there's default via .113. Now finally we will do this for the third machine as well, which is Gopal child. We go to the network connections. And go to the IPv4 settings, and we will set the gateway. We will set the gateway as 97. This is the lower interface of the third router. Again, we will be refreshing, like restarting the network manager. It is connecting and reconnecting. Now, if we check IP route, there is default via .97. Here we can see the IP address of the child machine. Here there's only a single network adapter, unlike our router. So there's only a single interface. Now Gopal will explain further.
Now we will start the Zebra and RIPD services using the command system CTL start zebra.service. We will just remove the Wireshark from the router. Yeah. Okay, now we'll start the Zebra service and RIPD service using the command system CTL start zebra.service and for like RIPD service same in the routers Naveen light one. We'll do the similar thing for the Lenoah light 2, the router 2. RIPD service. And then we'll do same thing for the router 3, Gopal light 3. Now as you see the response over there, yeah, the response like .65 and the source is the .65 and .74 is the destination RIP-v2. Now we go to the child machine 3, like we have 3 childs. So we go to the child 1, Naveen side, and we do the ping, like the communication between the machine, like the child, like child in the network, internet 1 with the other childs in the other network, other inmates. So 172.16.20.115. So it's the child in the internet 2. And as we see the pin like it worked and we got the response, and similarly we do it for 20.98. This is child in the internet 3. Now we'll do with like in the second child, and like second child in the internet 2 we have Lenoah's child, and in that we'll do .20.98. is in the internet 3, and yeah, as it's seen, it's successful. We got the response. Now now as we see here, like we can see the source like the .115 and the destination as .19. .115 is basically like the Lenoah child, the second child, the child in the internet 2, and .98 is the one like in the internet 3, the ICM. Now if you see the IP route, like we have this thing .96/28 .90 via .74. So .74 is this like machine 3's upper interface address, the router's upper interface address, and .96/28 is like for the machine 3. Yeah. Similarly, we check for the second router, second this thing router, and same thing for the third router, the Gopal Light 3. And we have similar thing like .80/28. .80 is for the machine 1, and via .20.65. .65 is like machine 1 here. That's it for the part 2A.
Okay, now we will start the demo for task 2B part. In this part, we try to configure our routers with OSPF. So, OSPF basically what it does is it will get the data of all the links of its neighbors, all the neighbors attached to it, and what it does is in its local system, it will try to make the topology of the whole network. It will make the whole network structure inside its local system. Then what since it has the whole graph structure with the local system itself, it can calculate the shortest path using any algorithm, but most probably it will be using Dijkstra algorithm with some modifications. So this is a bit more recent protocol than RIP. RIP is a bit older protocol. The reason is that we have to get a lot of information since networks can be quite huge and you need to get all the links data. Then only you can make the complete topology graph. Then only you can find the best route that your packet should take. Okay, that's all. Okay, I'll ask Leno to continue on the presentation.
Okay, so moving on to the practical part. So initially we can see that there are no routes configured before. So actually the first step you have to do here is setting up the IP addresses of the interfaces of the router itself. This is something we already did in part 1's B part. So then that is a Zebra config. And other than that, you also have to do the default gateway configuration, which we already did in part 2A. So if you're doing from scratch, you can refer to that. So now what we're doing is we have to enable OSPFD. Okay. So we'll go to the daemons configuration and enable OSPFD. Since we did RIPD before, we had to disable that. So we will do this for all the machines. So here we are telling OSPFD to stay awake, and it will keep running in the background. And you might notice in the side that oh no, that is after we start the service. Yeah. So now we'll do the configuration for OSPFD. And over here, we are setting it up to be a router, and we are mentioning the supernet. We have to do the same thing for all three machines and make them routers. And you might notice for all of them that the routes, it has no pre-configured routes. Now we have to enable the services. So first I think we'll enable Zebra. And then we will enable OSPF. And as soon as we enable it, you can see that there is OSPF hello packet sent. You can see the interactions between the system by observing the source and the destination IPs. And we have to do this for all three machines. So here again we are starting the Zebra service, and next we'll start the OSPF service. So there it is, the hello packet. Now we're doing it for the third machine as well, the third router as well. So we'll start Zebra. Then we'll start OSPFD. like Naveen said, by now it should have mapped out how the network is. So we can see the different OSPF acknowledgement packets and such. And now if we check the route table, we can see the routes have been discovered. So here we can see the route between 96 and 74. 96 is the third the third machine, and 74 is the upper interface of the third machine. So we can do this for all three machines, and you can see that the routes have been set up. And now Gopal will explain about the communication.
Okay, so now as we did communication, like now we'll just check IP just to confirm the IP address of that child, whether it is proper or not. And similarly, as we did like IP road, it will have only one interface. So it's like .81 for this child, like the gateway thing of like for that child. Like for her first child, it has the router one's gateway, which is like .81. So we have that as here. And .8028 is basically the base IP address of that internet. And now we'll just communicate with other child or for just to confirm like, whether the communication is possible between them or not. So we'll use pin 172.68.20. Point 115, which is the IP address of the child in the second internet. So as we see, it's successful. We are receiving the response. The packets are transmitted, and we'll just try with the third internet also, the child in the third internet. And similarly, as just as above, we got the response like the three packets are transmitted. Now we'll just check in the second child also, like the IP road. So as we see, .113, which is the gateway for it, like the router 2's bottom this interface address, which will act as a gateway for that net inside that for the childs. And 112/20 like 112/28 is for that base address of that internet. And now we'll try to communicate with other childs through this child. So yeah, 98. So we'll pin like .20.98. .98 is the IP address of the child in the third internet. So as it's seen, it's successful. The packets are transmitted. We see the ICMP packets and all. Yes. The base address is .98 and destination is .80. .85 is the source and destination is .115, which is the machine 2's child's address.
That's all for our assignment. Thank you.